right, this is the second video of a couple of videos on how to write the equation of a line, the slope-intercept form equation of a line, given certain information. So now these two word problems are basically that we'll go through. We're going to talk about how to find the equation of a line given a point and a slope, a random point, not necessarily the y-intercept, and how do you do it given 2 points. So again, this first example, the annual household cost of telephone service in the United States increased at a relatively constant rate. Now that word rate makes me think, well, remember slopes can also be called rates of change. The other hint to us is that that rate is $27.80 per year. So as the years go up, so does the money, right? As the years go up per year, the money is going to go up. Again, that sounds a lot like a slope. So from 1981 to 2011, again, we've got a $27.80 per year increase. So the first thing that I'm going to do is I'm going to write down that M equals 27.8 because I think I know my slope right there. In 2001, the annual household cost of telephone service was $914. Now that might just sound like random information, but remember, in order to find the equation of a line, we need the slope and we need the y-intercept. So if, let's say, our experiment started in 2001, if that was t equals 0, right, the beginning, then 914 would be my y-intercept. However, let's read part A here. Let's write an equation that gives the annual household cost of telephone service as a function of the number of years since 1981. Well, that means that 1981 is going to be year t equals 0. And when we go back, 2001 then, right, is 20 years later. That means that in year 20, we've got a household cost of $914, right, grand total, right? Well, in that case, we know a point and we know a slope. So if we want to write an equation, I'm going to need to find the b value. Now I'm going to read ahead a little bit because in order to figure out where to write all my stuff down, you'll notice I don't have a lot of room on my page here. Notice that part B asked a very kind of interesting question. What was the annual household cost of telephone service in 1981 at t equals 0? Well, that would essentially mean that when we plug in 0, I want to find this cost, right? That's basically saying find the y-intercept, or what this is saying is find b. Well, if we take our y equals mx plus b equation, right, and we insert what we know, well, I know a y value of 914 is equal to a slope of 27.8 times x, well, when y was 914, x was 20, plus b, right? I'm just inserting for x and y the coordinate that I already know. Let's do a little bit of math here. 914 will be equal to, now I'm going to need my calculator for this. 27.8 times 20 might be a little bit tricky. So don't be afraid to pump that in your calculator just to be sure we don't get the wrong numbers. 27.8 times 20. Maybe you can do that in your head. Did you get 556? I sure hope so. So let's call that 556 plus b. To solve for b, I need to subtract that 556 from both sides. And b will equal whatever 914, right? 914 minus our 556. It looks like that's $358. So our answer here, right, is going to be $358. That should be the cost, again, in 1981. That would be the cost when x, or for us t, equals 0, right? The cost at the beginning of our problem. Well, now I can go back to part A, write an equation. Well, hey, I know the slope. I now know the intercept. So again, we can say the cost will be equal to the slope, 27.8, times t, right, the year since 1981, plus 358. So we have our equation right there. And now we have the equation, we can do a lot of things with it. Assuming the model holds, find the household cost of telephone service in 2016. Well, the cost will be equal to 27.8 times. Now I'm going to need to know what year to plug in. Again, t equals 0 was 1981. T equals 20 was 2001. Well, 2016, right? 2016 minus 1981, right? How many years since 1981 is that? Well, I believe that's 35 years. So we're going to plug 35, right? 27.8 times 35, 35 years since 1981, plus our 358. Let's type that into the calculator. 27.8 times 35. We may as well type it all in at once, plus 300, and I believe it was 58, correct? Let's make sure we got the right number. 358, yep, it's right above there on the screen actually. $358. And it looks like 1,331. So our total cost, according to this model, would be $1,331 in 2016. All right, let's look at another model really quickly here. This one's about the population of trout in a lake, and I'm going to move a little bit faster this time. Again, we needed some information that we know. So now you'll notice up top here, I don't see anywhere that it says the word per or anything that's going up as something else goes up. But what it does tell me is that we know the population in 1995 and we know the population in 2001. Well, if we're going to measure everything from 1990, right? Any year after 1990, well, 1995 would be year 5, and we know the population in year 5. 2001 would be year 11, right? That's 11 years later. So again, we know the population in a year 11. And if that's the case, well, hey, we know 2 points. We can find the slope, right? 63.7 subtract, right? 44.5 over 11 minus 5, or m is going to equal, now I want to make sure I get these numbers right, so I'm going to be very careful, 63.7 minus, again I want to make sure I have my numbers right, 44.5, and we're going to have 19.2, and I'm immediately going to divide by, well, hey, 11 minus 5 would be 6. So I'm just going to go ahead and say divided by 6, and that's 3.2. So I'm going to have a slope, right, of 3.2. Well, now that I know the slope, I just need the y-intercept. So let's go ahead and pick a point. I'm going to grab the second one this time. Doesn't really matter which point you pick. The population was 63.7 with a slope of 3.2 in year 11, and I'm looking to find the y-intercept. So again, 63.7 is 3.2 times 11. So again, a great time to go to our calculator. 3.2 times 11, enter, is 35.2. Plus b, let's subtract that 35.2. And b will equal, well, as long as we've got that 63.7 on our calculator, we can subtract 35.2 and get 28.5 right there. And we have a model then. The population will equal 3.2 for the slope times t for the input plus 28.5. There's an equation modeling the number of trout or the population of trout in thousands any year after 1990. So if we want to know 2010, 2010 would be 20 years later, right? This is t equals 20. So let's go ahead and punch that number in there. 3.2 times 20 plus 28.5. Again, we'll do one more bit of calculator work here. 3.2 times 20 plus 28.5, and find out that our population will be 92.5, or P equals 92.5. Now remember that we're measuring this in thousands, so that's 92.5 thousand, right, trout. And that would be our answer there. I hope that helps you with the word problems when you're talking about finding equations of lines, right? Slope-intercept form equations. Make sure you type up those 2 points. Make sure you find those 2 points if that's the type of information you're given. Once you have the points, then we just do the math. Find the slope, find the intercept, write our equation, and of course, go find more information if we need to. If you have any questions, talk to your teacher. Otherwise, have a great day.